Hello guys, thanks for coming back again if you are subscribed. If you are yet to subscribe, please click on the subscribe button and also on the bell beside it. That will notify you when we drop a new video. Thank you. So in this video, we're going to talk about the WAEC 2021 Physics Practical and Optics. So and this is the question we're working with. And as we can see in the question, we have the diagram that we need to interpret in the real life. So provided we've gotten all these materials ready. So in the diagram, we have a ray box. Let me read through the question. The question says you are provided with an illuminated object. The illuminated object is an object that produces light, or better still, light falls upon it, then you will be able to see that object. So we have a ray box, and this is the ray box here. So we are going to connect these to a source of light and light it up, then we produce light. So now you are also provided with convergent lens, which is convex lens, and this is it. It's a convergent lens. A convex lens is a convergent lens, as you can see. So that is a convex lens. Then you are provided with a screen. So this is a screen. This is a screen. This is where image formation takes place. So that is how the screen looks like. So we have also meter rule. We are having meter rule here for a certain measurement. So that is function of meter rule and other necessary material. The necessary material we need rather here is the lens holder that we're going to make use of it to hold the lens in place, because in terms of experiments, when you have to set the lens into a certain position, so this will help you out in doing that. So that is the function of the lens holder. So let's move on. It said measure and record the size of A naught of the illuminated object. However, if you look at this ray box very well, you will see that there is a wire crossed on the face. This wire happens to be the object we are meant to find the image on the screen. So this is the object A naught, of which we're supposed to determine the size, which is the height. Both this and this, the two. We're going to determine the height and this, and probably that the height is what we call the size. So when we determine that, that will be our A naught. So measure and record the size of A naught of the illuminated object. We are going to determine the size of A naught now. So when we determine, I just want to read through the question before we start the experiment. So then place object O on the screen, and the screen S on opposite side of the convergent lens. So which means that we're going to place the objects and the what? The screen opposite side of the convergent lens. So the convergent lens is going to be at the center. So that is how we're going to place it. Then set the distance between objects, and the distance should be U. Anyway, so set the distance between the object and the lens U equals 30 centimeters. So which means the gap that will be between the lens and the object is going to be what? 30 centimeters. So we're not given the gap between the image and the screen rather, and the lens. So now we move. Adjust the screen until a sharp image of the illuminated object is obtained. So we are going to adjust the screen, move it either forward, backward, until we observe a sharp image of the object. So that is a sharp image of the object rather. So now then measure and record the new size of that image. We measure and record the new size of the image on the screen. So thereafter we can proceed to evaluate M equals A, that is the new size, all over A naught. And that will be in our table. Then we also evaluate M inverse, that is after calculating M, we find M inverse, of which everything has been loaded into this table. We have the U, which we are meant to work with. So we have repeat the procedure for 4 other values. We're going to take the measurement of, we're going to set the distance, object distance, to be 35, 40, 45, and 50 respectively. So in each cases, we are also going to measure or calculate M and M inverse. So thereafter, we have that in our table after the experiment. Then this we're going to evaluate. And mind you, when you are making your evaluations, this is in 3 decimal place. You can decide to make it 2, no problem. And these should also be in 2 decimal place. But when you are making this evaluation A over A naught, it should be in 3 decimal place. And this also should be in 3 decimal place. All recordings actually supposed to be in minimum of 2 decimal place. So I can still be, because this is direct values given to us, so we can still put this in 1 decimal place. So I will agree with 2 decimal place here. Then these ones where we make evaluation, we put it in 3 decimal places. So that is how it is done. Then thereafter we plot, we tabulate our reading, which is what I've just explained. Then plot a graph of n inverse against u. We are plotting the graph of these against u. Then determine the slope of the graph and intercept on the vertical axis. Then thereafter we determine the value of u for which m inverse equals 0. Then we'll proceed with the question. So let's see how it goes. Let's start it. Okay, so the experiment is about to start. So as you can see the ray box here, this is the ray box and this is a meter rule. So we have our lens holder and the lens at the center, then the screen down there. So we're going to set the distance between the object and the image, which is from here all to here. So that's first setting should be 30 centimeters. So let's see how it goes in the experiment. Let's see how to do it. So let's take the measurement of the object first. So to do that, I go on taking the measurement, and this is giving me about 3 centimeters or thereabouts. Yes, I'm having. If I take it from here, so I'll be having 3 centimeters. Okay, let us target the one standing, not actually the one crossing. So let's look at this major one, the one standing here is what we'll concentrate on. So we have taken the measurement of this one, let's forget about this, but both are just crossed. So now, since I've taken this and I'm having 3 centimeters according to this, that is right from here down here, I'm having 3 centimeters. So my A naught is going to be recorded as 3.0 centimeter. So I have done that now. So the next thing is to go for the line of action. So I have 3.0 centimeter there as my A naught. I've recorded in the table. So now we are going to take our readings, and the first reading says we should set the U to be 30 centimeters. So which means the line here should fall on the 30 centimeter. The line here, the line of symmetry here should fall at the 30. So, and that is going for 30. So, and don't forget we have this. So since it's on 30, then we'll begin to adjust the screen. I think I adjust backward first. So then I adjust it forward again. So I can see the sharp. Okay, let's move further away again. So it's getting blurred. So let's move closer. So I think it's around this region. So the image is sharp here. The sharp image has been noticed on the screen. Can you see that? So then we take the reading or the size of that image. So let me measure the size of the image. So by doing that, I'm going to measure the height. So in order to prevent obstruction, so I take my measurement right from the 0. So and this gives me 3.2, 3.20. So I have 3.20 here. So now let's go for the next measurement. So the next measurement say we should make that 35. So we should adjust this to 35 and see what would happen. So if we adjust this to 35, then we need to move either farther away or closer. When we move closer, we got, okay, since we measured the height of the one standing, so I wouldn't want to take or let's just take this. So we have this, and the corresponding height of the image formed here is. So now when I said the measurement now is 2.0
This is 2.5. 2.5. So let's put that on the table. I have 2.5 for 35. 2.50. So now let's move to the next one. So that is when we go to 40. So that is 40. So when we move to 40, what will be the size of the image? So moving backward, we discover that it appears blurred. So on getting to this point, I think I've seen the sharp image. So then the point of the sharpest image is what we should anticipate or we should look for. So, and this is, yeah, this is this point now. So I think this should be set in 40. Okay, good. So we have this. Now let's take the measurement of that value. If we take the measurement of the size, this gives this is 2 points. 2 points. This actually gives 2 points. 2.4. Oh. Okay, I'm saying 2.3 rather. So now let's put that also 2.30. So let's move to 45 centimeter. So if we place that to be 45, so what would happen? So can we see that? Okay, the image gets diminished as we increase the distance of the object. So I think we have the sharpest image here. It's around this region. So now we can take our measurement from here. So taking the measurement from here, I have okay, this is 1.8. We have 1.8 here, so let's put that into recording. 1.80. So lastly, let's move to 50 centimeter. So 50 centimeter, what are we going to have as object height or size? So that will be very, very small. So but still take time to measure that. So it is observable now. So let's take the measurement. So this gives 1 point, that is 1.6 1.6 actually. So we have 1.60. Okay, now let's make evaluations for the table. So we have A, which means A over A naught. We're going to calculate that. So now let's evaluate the values in the table. Like we have A over A naught. The first one is going to be what? 3.20 over 3. So and that gives 1. This is, we have 1.067, and that should be in 3 decimal place. So then we have the next one to be 2.50 over 3. So 2.50 over 3. So that gives us 0.833. So then the next one we have 2.3 over 3, 2.30 over 2.30 over 3. So that gives us 0.767. So then we have the next one, which is 1.8. So we have 1.8 over 3.0. So and that gives us 0.6 straight away, but I have to put 0, 0
because it has to be in 3 decimal place. So then the last one we have 1.60 divided by 3. So that gives 0.533. So we can now evaluate our m inverse in this case. So then we have 1 all over this will give us the m inverse. So 1 all over 1.067. So that gives us 0.937. That should be in also 3 decimal place. So then we have the next one, which is 1 all over 0.833. So that gives us 1.200 in 3 decimal place. So then the next one we have 1 all over 0.767. So and that gives us 1.304 actually. So after approximation. So then we have the next one, which is 1 over 0.6. So and that gives us 1.667 after approximation. Then we have the last one, which is 1 all over 5.33. Sorry, 1 over 0.533 rather. So we have 1.876. So this is the table. Then we can go ahead to plot our graph. So let's see how the graph will be plotted.
So now let's plot the graph. The graph title is graph of that is m inverse against u. So and considering the scale, we would have that, let's use 2 centimeter to 0.5 units on m inverse axis. This is how it should be written, not x and y axis again. So then we have 2 centimeter to 10 units on u axis. So now we can start plotting. So if we do that, that means we're going to have 2 centimeter here to represent 0.5. So from here we have 0.5, 1, 1.5, 2, 2.5. Actually, our values is up to 1.8. It's just 1.8, but actually we can make it 3. So we can actually start the graph from the center here. So if that is 0.5, 1, 1.5, 2, rather 2.5, 3, you can stop here. So let me repeat again. This is 0.5, 1, 1.5, 2, 2.5, 3. So we are picking it from here. So where is it? Let's pick it from there and draw it. So now I've put that. So here I'm going to have 0.5. This is 0 to 0.5. And I'm having year to year to be 1.00. So let me make it 2 decimal place. Then here I will have 1.50. Then here I will have 2.00. Then here I will have 2.50. And here I will have 3.00. So since I'm using, and this, don't forget the unit is not available, so we still put m inverse axis, and here is going to be u in centimeter actually, so that we can now put 10, 20, 30, 40, 50. So then we can plot our graph. So in doing that now, let's consider the values. For 30 centimeter we have 0.9. 0.9. So looking at that, since each box represents, so then we read our 0.9. So and that means we are interval of two box from 0.5. That is here we're going to have our 0.9. And that goes for, actually this is not where we are meant to put it. We are meant to put it on 30. So that is 30 to, when we trace it out to 30, here is going to be the points where we find it. So we are meant to draw this completely because we still need an intercept actually. So we draw that completely. So then let's move on. We have picked up that value, that is this. So now let's go for the next value. We have 35 to 1.2. 35 to 1.2. So this is 35, should be at the middle. Then we have 1.2. So this is 1. Then 1.1. And then 1.2. So we can mark our point here. 1.2. So then we go for 40 to 1.3. We have 40 to 1.3. This is 40. So let's take it to 1.3. So this is 1 actually. So we have 1.2 here. So here will be what? 1.3. Is that it? No, that will be here. So here is going to be the 1.3. So two intervals. So we have 1, 2, then here will be what? 1.3. So then we go again for 45 to 1.7. 45 to 1.7. This is 1.5. Then we have 1.6. Then 1.7 will be here. So let that be 1.7. So then we have the last one, which is 50 to 1.9. So 50, that is after approximating in the table, 50 to 1.9. So we have 1.9 to be, this is 1.5, 1.6, then 1.7, 1.8, and this is 1.9. So we pick it there. So thereafter we join the points together. So let's join the points together and see what we do, what will happen. So I think only one point is left out, so let us draw that. So with 1 point we can still go. So we trace the line big to this point, so and that happens to be the intercept on y-axis. So this is the graph. Now let us determine the slope of the graph according to the question. So the slope of the graph will be determined. We only have 1 point left, and this one, even this just stick away from the point, so that's both sides. So let's just pick up from there. So drawing the slope, we have this. So let's actually make it bigger. So then we go to these points. So I can rub this side. Now I have my change in M inverse and I have my change in U. So don't forget that here now we have 2.0, sorry, and that is 1.9 rather. Then here we have 0.25 divided by 2, 0.5 divided by 2 rather, so and that gives us 0.25. So that is, which means we are going to have change in M inverse equals 1.9 minus 0.25. So that we go for change in U, and change in U equals 50 to, what do we have here? So since this is 10, that means we're going to count 1 1. So and this is 10, we have 11, 12, 13, 14, 15. So let's trace it down through that point. So I think I'm having 18 here. I'm having 18. So, and that is 50 to 18. So that is 50 minus 18. So don't forget that the slope S of the graph, is equals to the change in M inverse all over change in U. And that will give us 1.9 minus 0.25 all over 50 minus 18. So with that, I have 1.65 over 32. So we have 1.65 here and 32 here. After dividing, so we have 0.051 as the slope of the graph. So now that is the slope of the graph. We can proceed to do the remaining calculation on the board. Also, the intercept C of the graph can be read from here. So this is 0, and here will be what? Minus 0.5. So on getting here, we have each one to be. So reading the slope of the graph, we have 0, and this is minus 0.5. So we are going to have minus 0.6 here, and not exactly at minus 0.7. So let's take that to be minus 0.69 or 7. Let's take it 7. So that is slope is equals to negative 0.70. Intercept is equals to negative 0.70 as it is. So now the graph is fully plotted. So then what next? We have determined the slope of the graph, the intercept of the graph. Let's proceed with the question. The question says determine the slope S. We've done that. Intercept on y-axis. Determine the value of u for which m inverse equals 0. So which means that I will go here and find that point where m inverse is 0. Then trace it to the line, just 0. Then let's trace it to the line that touches x, that touches u. So I'm getting the value of u to be, this is 11, 12, I'm getting 13. So u will be 13 when inverse of the multiplication is 0. So we say that question xi is when m inverse equals 0, u is equal to 13 centimeter according to the graph. When you read, that is from 0 to the line touches the axis at 13. So and that is solved that. Then state 2 precautions to obtain accurate results. Actually, I avoided parallax error in making use of the meter rule. You have to name the instrument used, or the instrument of which you avoid the parallax error. So when making use of the meter rule, I avoid parallax error. Then I ensure that the source of light or the ray of light is concentrated or is focused on the lens properly. And I ensure that I capture the image produced at the sharp point. There is possibility that you have sharp or sharpest or whatsoever. So I capture the image size at the sharp point of the image when it is formed on the screen. So you can have more and more precautions as you proceed on the experiment. So lastly, they said using your graph, find m when u is 37. So we can also use our graph to do that. So here we have 30, we have 31, 32, this is 35 actually. So 36, 37. So we are tracing that 37 up the graph. 37 up the graph. On touching the graph, I am having 1.25. So which means that when u is equals to 37 centimeter, that means we are going to have our m inverse to be 1.25. So that marks the end of the question. Thanks for watching. Please subscribe for more series of video coming up for the WAEC and also for the advanced courses. Please subscribe to our YouTube channel. It is free. Thank you.